In this case study question from the chapter Permutation, we are given that Sagar, which is a class 11 student, who has been anxiously waiting for having get together with his classmate, as he could not be with them for a stretch of 2 months due to examination preparation. He invited four friends, Ram, Ekta, Sahil, Sasi, on his birthday party. So these I can see there are people, four people he invited, one, two, three, four, and including him, it is five people. Now, after the cutting, they wanted to take a group photograph sitting in a single row. So what I have done, I've made a row here, placing them as one, two, three as the single row. And I marked it one, two, three, four. Not necessarily you have to do that, just to understand. Now, in the first part, they're asking how many distinct photographs can be clicked. So distinct is what even one person, like say if I arrange like this, say Sagar, Ram, Ekta, Sahil, and say Srishti. So even if I just displace one, right? Even if I displace one from here, this is going to be another photograph. So we'll call them as not same as the previous. So we can see that there are five places, five people here. So, or five objects that can be arranged in five factorial ways, right? And as we can see, no two objects are identical. And so we can say we can either write 5 factorial, which is 120 only, or you may write that is 5p5, 5p5, and that is also 5 factorial, which is equal to 120. So we can say 120 is the answer for the first part. So 5 people can be arranged in distinct way, and these distinct ways by which they can be arranged is 120. So this is 5 factorial, which is equal to 120. Now let's read the next part. In the next part, it says that how many ways photographs can be clicked so that Sagar is sitting at the middle. So middle position, as I can see, will be, say this is Sagar. This is Sagar is sitting over here. So we can see that after fixing Sagar, we are left with four different slots, right? Or the chairs or the places where these four people can swap their positions and exchange their positions. So we can say that fixing S at the middle, that is central position, fixing here S, we are left with four slots which can be arranged in 4 factorial ways. So that will be 4 factorial, which is equal to 24. So that is the answer for the second part. We got the answer for the second part. And that's answer is, which is equal to 4 factorial, and that is equal to 24, which is equal to 24. Now coming to the next part, it says how many photographs would Sagar and Ekta be sitting next to each other? Okay, so these are 5 people. As you can see, these are 5 people. And the condition is that Sagar and Ekta should be sitting next to each other. So we can say these are the possible. I can place Sagar over here and Ekta being here. Now, second possibility like this, if we keep on shifting, let me write it properly. If I write Sagar and Ekta, now check what are the possible ways by which I can arrange them. Yeah. So this is one possible ways. Then Sagar, Ekta shifting next. So second, two possible ways, three possible ways, and four possible ways. So you may say that this is 4 ways by which they can be set. But then it's not given that Ekta should precede Sagar or Sagar should precede Ekta. So they can be other way also. That means Ekta being here and Sagar being here. Right. In that case, we have another 4 ways. One, this is 1, 2, 3, and 4. So that is 4 into 4 plus 4, you should say, or you may write 4 into 2, whatever, that's all same. You may write 4 plus 4, that is equal to 8 ways by which there are 8 possible ways by which Ekta and Sagar can sit together. But then we have to also think that after Ekta, like placing Ekta and Sagar next to each other, we are left with one, two, three places. And these three places can be occupied by three people in three factorial ways. That is 3 into 2, which is equal to 6. So therefore, the total possibilities will be what? 8 into 6, that is equal to 48. Well, you may take it like this also, that is 2 into 4 as 8, or you may write 4 plus 4. So we can say that the answer for the final part, which is here, for the next, that is, this is equal to, we'll write is equal to 8 into 6, that is equal to 48.